Here in section 3.4, we are looking at contingency tables, which we have actually seen before. Contingency tables are just a tabular view of values that relate to variables. Here they're going to be political party and then geographic region, urban or rural, that might be dependent to each other. So considering this data below for 737 randomly selected U.S. residents, we want to know what is the probability the person is a Democrat. Well, let's assign some labels to our events here. So let's let D represent Democrat, R Republican, I Independent, U will be urban, and then rural, why don't we do RL for rural. So the probability the person is a Democrat, so this is probability of D, and this is going to be desired outcomes out of total outcomes. So our total is 737, and out of those 737, Democrats are 329. What's the probability the person lives in a rural area? So that's probability of RL. Again, desired out of total. Our total is 737. Rural area total is 348. What is the probability a person is an independent and lives in an urban area? So this is probability that they're an independent and live in an urban area. So U, I and U. So this is going to be, let's see, probability of U. Well, we can do the first one, I. So we can do probability of I times the probability of U given I. So that's a multiplication rule. But actually, we don't need that here. We would get the same answer, but actually these values in the table are and probability. So independent and urban area, independent and urban, there were 24 out of 737 desired out of total. So that's all we needed there. Probably the person is an independent or lives in a rural area. So probability, independent or rural. So we are going to, an or is addition rule. So we're going to add these two probabilities and subtract the overlap. So probability that they're an independent, 60 out of 737. Plus they live in a rural area, 348 out of 737. And then subtract out the overlap here. So independents are here, rural area here, and we can see 36 was counted twice. So you have to subtract out that 36. And this gives us, with the calculator work, 372 out of 737. What is the probability the person is a Republican given that they live in an urban area? So this is probability of R given U. So remember, your given condition restricts the denominator, restricts your total outcomes. We're only looking at the urban area, which our total is 389. And then it's given we're in that column, what's the chance they're Republican? Well, we had 120 here out of that 389. What's the probability a person lives in a rural area given they're an independent? So probability rural, RL, given I. So again, that given condition determines your denominator. So total independents were 60. And out of those independents, those 60 independents, how many lived in a rural area? And that was 36. So 36 out of 60. And then, let's see, are the events Republican and urban independent? Well, we want to compare the probability of Republican and the probability of Republican given urban, and see if those two are the same. So Republicans, there were 348 out of 737. And then Republican given urban, oh, we did that one up here, 120 out of 389. And this is closer to a third, this is closer to a half. Those are not equal to each other. You can check the decimal for each one, but they're not equal. So no, not independent. Are Republican and urban mutually exclusive? Well, our Republicans are here, urban area are here, and we can see that there's 120 in the overlap. So no, they are not exclusive. There is overlap. $120. So we did a lot of different rules in that example. So that's a great review example.